And welcoming Katie to the stage. She's going to be talking about moving .NET and Windows services to Linux.
Yep, cool. All right, this is me and Katie Bell. This talk has kind of two themes to it. One is trying to move stuff from Windows to Linux, and the other is trying to get your managers to agree to a sort of large tech debt cleanup project. So we've got kind of two themes running through side by side. But to start off with some context, I work at a company called Campaign Monitor. Campaign is for marketing campaign, not like political campaign. It's an email marketing platform that businesses use. You can make fancy looking emails that work surprisingly well across many different email clients. And in the history of Campaign Monitor, which was started around 2004, software has gone through several different sort of generations of how we build software. And this is fairly typical of a lot of different companies, because in the beginning, there was the monolith, and everything was built into this one sort of monolithic web server, and that was the entire product, everything in one code base, everything deployed in one go. Who has worked with a monolith? Yep, cool. Who has then moved to microservices and then hated it for some other reason? Yeah. So the monolith was, runs in Windows, written in C# using the .NET framework. It uses IIS. If you're not familiar with IIS, it's kind of like Apache. And it has one... and it has one giant SQL Server database. And following the trend in the software industry, Campaign Monitor decided to do microservices. And because it was a Windows company with everyone using C# and .NET, of course they built the microservices in C# and .NET as well. And this is nice. You get to sort of deploy independent components separately from each other. You don't have the kind of monolith problems that you have where one person sort of commits a breaking change. You have to halt the release. That holds up all of the other developers getting all of their other things out to production. So in the microservices world, you're better able to kind of independently deploy separate pieces, which is nice. But this means that you have, multiple separate pieces, and you have to kind of set it up and deploy it and maintain each of those separate pieces, and that's a lot of overhead. And so the engineers at Campaign Monitor built this thing called Reckless. This is not a judgment of the framework. They decided to name it Reckless. I'm still not entirely sure why. No one will tell me. And so we have this thing built in Campaign Monitor called the Reckless Microservice Framework, and written in C# and .NET. Moving away from some of the old kind of web hosting IIS stuff and using more modern web hosting, so each service is independently web hosting. It doesn't have to deal with IIS running on the host system. And lots of small independent modular components, which is quite nice. It even had like its own kind of command line tool. The developers love this framework, right? It makes it super easy to create a new microservice. So you can run one command line, infra ms init, and it creates the Git repository, it creates a deployment pipeline. You can then run one more command, deploy, and push out your microservice to production within about 10 minutes of getting started, which is nice. You can create as many new microservices as you want until you have far too many of them. And there's a lot of really cool properties about having things be this easy to use. Of course, when you deploy your microservices, it doesn't do anything until you actually write the code, but quite a neat framework. One of the downsides of microservices is if you try to run each one in its own separate virtual machine on AWS, it would cost a lot of money. So of course, we run multiple services sharing EC2 hosts. And so you run ms deploy, and it will go through the provisioning orchestrator service, and it will load it onto some of the Windows host machines for you. So again, developers love this framework. It's quite nice. But then there was another shift, another generation in software development at Campaign Monitor. And that was largely due to this kind of effect. Now, this is the Stack Overflow developer survey from 2019. And is looking at developers who use technology A, how likely are they to also be using technology B? And it is a little bit hard to read, but I will point out the relevant bits. So Campaign Monitor was very much in this part of the graph. This is the sort of Microsoft ecosystem of tools where you're using .NET, you're using C#, and there were a number of open source tools that the Campaign Monitor engineers wanted to use to be able to build out new parts of the stack. And these were things like the things up here. So things like Docker, things like Elasticsearch, AWS tooling is over there. It's not in the Microsoft branch, like Microsoft engineers tend to use, Azure or something. When you're using AWS and you're running Windows, you are a little bit of a second-class citizen. The same for a lot of these open source tools, a lot of the big data tools that we wanted to use for data processing, like Spark. It's really hard to use these when you're writing C#. The client libraries aren't as good. They're often not officially supported. And you are constantly sort of battling, doing things in a way that other people aren't. So you're not making use of all of the communities around these products. And so partially this was a change in leadership, but also Campaign Monitor just generally decided to move more in the direction of running things on Linux and using a lot more of these kind of tools. And so we have a third generation of the way we do software at Campaign Monitor. And this is the sort of what I would describe as the Docker generation, where we're running things in Linux, we're running it in Docker. We use AWS ECS, the Elastic Container Service, to run those Docker images, which is kind of the poor man's Kubernetes. And everything is written now in Java and Go, and sort of moving away from that .NET world. And these are all sensible decisions as you go through, like, what is the problem with the existing system? How do we correct that moving forward? But the downside is, as you're an engineer working across the product, working across these 3 different generations, you now have 3 different ways of doing everything that you have to remember how to do, you have to keep the documentation up to date, you have to keep developing all of these. And it makes things really quite slow to work with. For example, if you're working with a particular web framework, it's useful if you're very familiar with that web framework, but we've got 3 different web frameworks in use. In the same way, if you want to deploy a change, we have some of the same tooling, but slightly different ways of deploying things, depending on which part of the code base you're working on. If you want to add logging, we have different ways of doing logging across these. If you want to know how your web requests are actually reaching your service, we had 3 different ways that that was happening as well. And if you wanted to sort of scale up some capacity, we actually had 3 different ways of doing that, sort of using CloudFormation in the old one, and we started using Terraform, and that means our developers need to know both CloudFormation and Terraform, even though these tools do very similar things. And so you have this kind of world where, depending on which part of the software you're working on, you have to take a completely different path and know a completely different tool set. And this is a big tax on your developers, right? This is wasting time. Kind of every time I move to a new bit of the code base, I have to relearn the tooling again because I've forgotten it by then. This meant that as we were trying to make improvements, I tech lead a team called Engineering Productivity, and our goal was to make life better for the developers. But if we made life better on one of these tool sets, it would not really affect the other 2/3 of the code base. And so consistency was really lacking in the system, and it made us slower. And we wanted to fix that. It didn't help that the Reckless Microservice framework, while it sort of looks nice and neat over here, it had a whole bunch of extra supporting tooling as well. And because we had started moving into this Docker universe, and several of the engineers that had originally built the Reckless framework had left the company, we were starting to lose kind of that communal knowledge about how all of these pieces of infrastructure worked. And so we had this kind of custom Nginx proxy system that hooks into the console service discovery system to route requests to the right path. Occasionally this would break, and we were lacking a lot of the engineering background and knowledge to go in and fix it easily. And a lot of these things kind of were starting to stagnate because this was not the new thing. This was not the thing that we were investing engineering time into anymore. It was starting to accumulate tech debt. So it was starting to bit rot, I guess. So a couple of engineers, not me, had a crazy idea of what if we could take all of these Reckless services and run them in Docker instead. And so that would mean taking them from sort of a Windows running environment from .NET framework, migrate them to .NET Core, run them in Docker instead, and then we could make this whole generation of software development consistent with the new generation of software development, so that it doesn't matter that maybe you're writing C# or maybe you're writing Java, everything else is the same, you just run it in a Docker image, and everything else around it, all of the tooling around it, is then the same. And we would be able to get rid of one whole generation of ways of doing things and clean up a lot of things in the process. And so on the Docker side, we then have sort of C# and .NET Core as just one of the ways, one of the things that you might choose to run inside a Docker container. And to be fair, we'd already started doing this. A couple of the C# engineers had kind of gone, we don't want to write Java. How about we put something, like write a new service in .NET Core and run it in Docker? And that had already been working quite well for us. But we were still stuck with the existing sort of more legacy software systems that we had. So what does it take? All right, let's take .NET Framework, migrate it to .NET Core, run it on Linux. What does this actually mean? So actually, we did a sort of show of hands before, but who works in .NET or has worked in .NET professionally? Yeah, a lot of you. OK, most of you would already know this, but for context, .NET Framework was first released in 2002, so it has sort of acquired a lot of APIs in that time. It has acquired a lot of things. The world has changed since then. Back then, Microsoft didn't really want anyone to be using anything other than Windows, and it was built specifically for Windows. There's a lot of Windows-specific things built into the .NET Framework. They tried to kind of pass it off as open standard, meaning anyone can implement this, but we're not actually going to give you an implementation. It has since been made open source, which is quite nice. .NET Core, on the other hand, is kind of, Microsoft has changed its image, and from 2016 and the release of .NET Core, it has been built from the ground up to be cross-platform. It runs just as well, if not better, on Linux than it does on Windows. It is entirely open source under the MIT license. And it has a little bit of a change of sort of methodology. It's a bit more targeted towards being able to write self-contained executable apps, rather than .NET Framework, where you sort of install it at the operating system, and you have to have the right version of .NET Framework installed for your particular app to run and hook into that kind of stuff. So a little bit of a different methodology. And now .NET can run on Linux. But .NET could always run on Linux because of the Mono project. So Mono is an open source project, which is a lot of the Mono developers have since, who were part of Xamarin, which has now been acquired by Microsoft. So a lot of the Mono developers now work at Microsoft, and there's a lot more code sharing going on between these projects. Mono is the open source version of .NET Framework. And it runs on Mac, it runs on Linux, there's iOS versions and Android versions. So you can take .NET Framework code and just wholesale run it in Mono, and that actually works really, really well. And a lot of the reason why we would want to go to .NET Core instead of just taking our Windows .NET Framework and running it in Mono is because .NET Core is the future of .NET. Microsoft has made this very clear. They're sort of slowly planning to remove support for .NET Framework, and everything is moving to .NET Core. That is what they want you to do. So if you're going to put a lot of effort into taking something from Windows over to Linux, you really want to consider sort of migrating to .NET Core at the same time, because it is future-proofing it a lot better than sticking with .NET Framework. And so if you're looking into this, you'll also find that, sorry, I need to go back a bit. How compatible is the .NET Framework set of libraries and the .NET Core set of libraries? And with the release of .NET Core 3.0 recently, they've announced that they've stopped porting libraries over from .NET Framework to .NET Core. So the first version of .NET Core did not have a lot of the .NET Framework libraries in it, and every subsequent version has had a lot more of .NET Framework supported over in .NET Core as well, by adding it to .NET Standard. And they haven't ported everything across. And they have this really great, energetic, we've ported over 120,000 APIs, which is more than half of .NET Framework, which really makes you wonder, OK, but that means there's half of .NET Framework that isn't supported over in .NET Core. Half of .NET Framework is not there in .NET Core. And they have built a lot of new APIs that cover a lot of the same functionality. So generally, the functionality that you're used to is there, but a lot of those APIs are new, and they won't just automatically port across. And so you have this thing called .NET Standard, which is kind of the common set of APIs between .NET Framework and .NET Core. So they each have their own implementation of .NET Standard. But it means if you are developing a library and you want that library to be used across .NET Framework and across .NET Core, if you build your library on .NET Standard, then it will be able to be used by both of these. So 2 different runtimes, and .NET Standard is that kind of API specification, not the implementation, for how to write libraries that are supported across both. And the really good thing is that a lot of the sort of third-party libraries that you will find out there that are commonly used, if it's been actively maintained, generally the support for .NET Standard is really good out there. And most of the libraries that you use probably support .NET Standard now. So there is a set of things that really doesn't port to .NET Core easily. And these are things that will take a lot more work to port over if you do choose to port over them. So first thing, a lot of the libraries, even if they are supported, they've been put into a different namespace, and so you have to kind of modify your code a little bit to import things from the right place. Again, as mentioned before, half of the .NET Framework libraries have been dropped, and so if you're using any of those, you will need to write code to migrate your code over to whatever the new set of libraries are, or find some replacement for those. In particular, IIS and ASP.NET have not been ported over. There is a new ASP.NET Core, which is quite different, has a new dependency injection system. And those things that kind of came with ASP.NET, web APIs, web pages, web forms, those are not porting over to ASP.NET Core. And so you are kind of, if you're using those things, you would expect to have to do a lot of work to be able to port to .NET Core. If you use WCF server communication, that is also not ported over. And if you have any like third-party libraries that you're using that for whatever reason aren't being maintained anymore and don't have .NET standard support, that is also an issue when you're trying to port those things over as well. We'll get to that a bit. But for going back to Campaign Monitor's specific situation with our reckless microservice framework, it turned out that we don't use a lot of these things, right? Our older monolith does use IIS and ASP.NET, so that's going to be a fun project in the future. But for the reckless microservice framework, we weren't using ASP.NET, and so that part of the system was a lot easier. We're using a framework called Nancy. Nancy, as a well-maintained open source library, did have .NET standard support. And so as we're looking at this, we're like, well, we're probably using the right set of things in .NET Framework that will, for us at least, make it easier to port to .NET Core, which is nice. So we decided this was not a crazy idea. How about we get rid of this whole generation of software, migrate everything to Docker, and the world will be a better place. Let's go for it. Let's do it. Who here works at a company where if you want to do a big tech debt cleanup project that might take multiple months, you can just go ahead and do it? Oh, wow. Man, where do you work? For the purpose of the video, there were like 4 hands in the room. I don't work for such a company where you can just drop everything and clean stuff up. You have to, but I do work at a company where that kind of thing is supported if you can make a good business case for it. So if you go to your manager and you're like, I really want to do this cleanup project, and they're like, okay, this is a big project. You don't know how long it's going to take. It has no customer benefit. It's not going to bring us in any more money. You think it's going to save some developer time, but like, you don't know how much. And you think it might save some money because Linux is cheaper than Windows. You don't know how much. And so if you ask like, hey, can we spend a lot of time? Can we start this project? Any sensible manager is going to say no. So we didn't ask for that. Got together with a couple of engineers, and we asked for something much, much smaller, right? If you can't convince your parents to get you a puppy, maybe they'll get you a guinea pig, right? So what we asked for was give us 2 weeks, okay? And it will not run beyond 2 weeks. It will be just 2 weeks. We're not going to try and do the project. We're just going to test if the project is worthwhile going ahead. So we wanted like 3 engineers for 2 weeks, and my manager and my manager's manager were like, yeah, like 2 weeks, sure. That's not going to put a dent in our development timeline. We're in a phase where we're kind of between projects anyway. And the possible benefits were quite big. And if we got to the end of the 2 weeks and we had concluded that the project was not worthwhile, that is still a really successful use of those 2 weeks, right? If you manage to rule out a project and you go, this is actually not feasible for us to do or not worthwhile for us to do, then that's great. You spent those 2 weeks really wisely. So what we did for those 2 weeks, we asked for 3 engineers, but then a 4th engineer decided to join us for fun. So we had 4 engineers. We spent the first week building like a really hacky proof of concept. We took one of the reckless services and we hacked away bits of it. We commented out large chunks of it until we got something that was vaguely working. And a lot of that time we spent getting the thing to start up because we were using a library for command line parsing that was not .NET standard. So we had to hack all of the options out of there, and so it's going to start up in one mode only. We had to change the web hosting, but we got a thing that ran. And then in the second week, we kind of stopped working on the project. We didn't want to move the project forward. That was not the goal of our 2 weeks. We spent a lot of time looking at, okay, how many different microservices would we have to migrate? How long would it take to migrate each one? As we were going through our proof of concept, we meticulously documented all of the things that we knew we would have to go back and do properly later, right? So we developed quite like a 10-page document of like, here is a giant bullet point list of things that we would have to do if we were going to do the project properly. And at the same time, we kind of started it running in Docker, threw it up into our staging environment so that we could then show with a pretty looking visualization that it worked. And then we spent the entire last day on time estimates, right? Going through our detailed list of everything that we knew we would have to do the project properly, and very generously like time estimating how long it would take. So we could come later on to our managers and say, look, this is why we think it's going to take this long. This is not just a number that we pulled out of our collective butts. The biggest thing that we discovered in this process that surprised us was this. What is the difference between these two things? Windows versus Linux, yes. So the top one is how much it costs for an M4 large, which is an M4X large, and so on, which is most of what we were using at the time on Windows. And if you use exactly the same compute resources on Linux, you get a 45% discount. For AWS, the Windows licensing cost is included in the price of the EC2 instances that you're running. And so Windows ones generally cost considerably more. And as we were looking at this, we realized that the cost saving alone of moving from Windows to Linux made the whole project worthwhile. Turns out Linux is free, who knew? Once we discovered that, we stopped spending as much time trying to justify the project because we knew we had a pretty good case. So when we went to pitch the project, we had a demonstration that it would work. We had really detailed time estimates. We could accurately say, like, this is going to take this many months for this many engineers. We proposed multiple different options. Like, maybe we'll do the groundwork for the migration, and then we'll leave it up to individual teams to migrate their services one at a time. Or maybe we'll just do the whole migration ourselves. And we were able to show concrete benefits. And we did do a bunch of work to not just show that there would be a monetary benefit, but also to show here are all of the cases where some of that infrastructure has broken over the last while, and so these cases would not have wasted engineering time in the future. And sort of showing these are some projects that are difficult because of the way the current system works. If we were to fix this, we would unlock this other things that would let us actually provide customer value in the future. So some concrete benefits, but for us, it was mostly dollar signs. So let's do this project. What does it actually take? Let's migrate everything. So if you're considering migrating a .NET Framework tool to .NET Core, I would highly recommend checking out the tool provided by Microsoft, which is the Portability Analyzer. There's two forms. There's a command line version. There is also a Visual Studio extension that you can install, which is what we used. You can basically just run it across any of your Visual Studio .NET projects, and there's a bazillion options for which specific versions of which things you're trying to test compatibility with. And it gives you a bazillion warnings about different things that are not supported across what you're trying to do. If you can't read that, it says system configuration, app settings is not supported on .NET Core. We suggest that you use a different configuration system. Yeah, that's very helpful. There's 2,000 messages there. It also gives you a handy XLS spreadsheet, which summarizes it for you as well. I don't have Excel, so I use Google Docs. And so this is a spreadsheet. Hopefully that's big enough to read. It gives you a very warm fuzzy of like, oh, we're 95% of the way there. And then it gives you a very detailed list of here is every single API call that you need to change, and it's like thousands. And this is not including the set of dependencies that you have where it's not sure if those dependencies are going to support .NET Core or not. So it lists like, here are the things that you depend on. For that, looking at your dependencies and checking if your dependencies support .NET Core, there is a different tool, which is conveniently the website icanhas.net, which is really cool. Like, you can upload your packages config, so the list of all of your dependencies and what versions they are, or you can just put in a reference to a GitHub repository and it will scan it for you. And it gives you like this fancy graph of like, here are all of your dependencies and your transitive dependencies, and which ones are supported and which ones aren't. And sometimes, for what we found, a lot of our dependencies were quite out of date. And so in most cases, the newest versions of our libraries that we were using did support .NET Standard. We just had to upgrade. And so as we were going through the project, sort of 4 major categories of things, and we'll go through them one at a time. The first thing that we had to overcome was the difference in web hosting. So .NET Core has basically a completely new sort of web hosting system called Kestrel. It's built on libuv, which is the sort of the server underlying node.js. It's fairly lightweight. It's very fast for simple things, and it's pretty good. That actually worked really well for us. As you're migrating over to this sort of new Kestrel system, we also sort of started using ASP.NET Core, and it has its own dependency injection system, but we were already using a dependency injection system, AutoFac. There is a bunch of stuff that lets them play nicely together, but we just had to figure that out. Once we got over that the first time, it was pretty easy sailing from after that. The thing that probably took the vast majority of our time was libraries that do support .NET Standard, because we had to upgrade through multiple major versions of those libraries in order to get to that .NET Standard support because our libraries were so out of date. And for something like the AWS SDK library, in one of those major version changes, they had made everything async. And so if you're a .NET developer, you know that once one thing is async, you then have to make it async all the way down. And so a lot of the time that we spent sort of going through each individual microservice and migrating it one at a time was just making everything async whenever we used AWS. The other thing was the Nancy sort of web framework that we were using had gone through some quite large API changes in the upgrade that added support for .NET Core and .NET Standard. And so we had to change a lot of our web code as well. We did hit some interesting operating system differences when we started running things in Linux. And in .NET Core, you'll find that like the libraries that do things like Windows service handling and like event logs, they don't exist anymore because those are specific to Windows concepts. So Windows services in the way that they start and stop and the way that you interact with that are quite different to Linux processes. For the most part, we kind of ripped out a lot of the Windows service handling code we did and just let it run as a process. The event log code that we had in, we just ripped that out as well. We had other logging that was more than sufficient for what we needed. We did get burned a little bit by case-sensitive file names, because Windows is case-insensitive, and so if you're fetching a particular JavaScript or CSS file with the wrong capitalization, it can't find it when you run it on Linux, but it can find it when you run on Windows. So we had to kind of go through and fix those, make everything lowercase. And we did hit a couple of cases where we had libraries that did not support .NET Standard. And Top Shelf is a very understandable case because Top Shelf is a library for handling Windows services. And so I think they've added a lot more .NET Standard support now, but at the time, it didn't really support .NET Standard at all. And since we were ripping out a lot of our Windows service logic, we kind of just ripped that out as well. We also used a library called Magnum, and I would recommend not ever depending production code on a library which has a tagline larger than the average .NET developer. And that was an unmaintained library. It was handling a lot of our command line parsing as well as some other stuff. And we just had to rip out all of that code and replace it ourselves. So don't depend on libraries that aren't maintained. Like, that's probably a good philosophy in general. We also found that like, you don't necessarily have to limit yourself to just libraries that support .NET Standard. And so the way that .NET and .NET Core work is that you depend on some kind of library compiled against .NET Standard. Underlying, it uses the .NET Standard DLL, which has an underlying implementation. For old school .NET Framework compiled libraries, they depend on MS Corelib and the sort of underlying .NET Framework assemblies. Microsoft has provided a compatibility shim that implements the MS Corelib and underlying .NET Framework libraries that let you just wholesale run .NET Framework libraries in .NET Core. And this sounds really good, but you want to use this with a lot of caution. And so firstly, it gives you all of these scary warnings in Visual Studio if you try and do this, which we did. So it says, the big text is so you can actually read it. Warning, a package was restored using .NET Framework version 6.4.6.1 instead of the project target framework, which is .NET Core. This package may not be fully compatible with your project, shrug. In a lot of cases, this will work if you're only using .NET Framework libraries that are equivalently supported in .NET Core and are supported by the compatibility shim. If it doesn't work, if this library does call something that isn't supported, you won't find out until runtime. So we use this in production, but we have done so with extreme caution and generally went with the approach of, if at all possible, we will use something that is .NET Standard and we'll put in the work to use something that is actually .NET Standard, but in some cases we have depended on .NET Framework libraries. And we haven't had any problems since, and this has been running in production for about a year. So hopefully good, but again, use with caution. So yes, overall, there are some differences in web hosting. If you're using IIS or ASP.NET, you're gonna have some fun. Libraries supporting .NET Standard were, for us, by far the largest chunk of work. Like updating all of our libraries, going through updating every single dependency did actually take quite a lot of engineering time. The OS differences ended up not being too much of a problem for us, and we only had a couple of libraries that didn't support .NET Standard, and you can work around that in some cases if you need to, so that's good. Overall, the project worked. We got funding for it. It did take about, depending on how you calculate it, 6 to 8 months. Which is about what we originally estimated it would take for sort of 2 to 3 engineers. We sort of planned for 3 engineers, but then one of the engineers got called off onto something, so we had 2 engineers for half the time. But we got there. We migrated all of the things over to Docker, all of the reckless microservices. We started out with more than 100 services, so I would highly recommend making it non-trivial for your developers to create new microservices, because then they create a lot of microservices. We found a lot of cases where there were like 2 microservices that did very tightly coupled things, and why are there 2? Well, there were 2 microservices because the original project had 2 developers, and they each wrote one. Like, this was very much like, you know how you have a problem of a monolith and you go too far, you overcorrect in the other direction, you have to sort of reel it in a little bit. So we started off with over 100 microservices. In the original project, we found that there were 78 of them running in production. And we identified that we really needed to migrate 43. Now, the reason that 43 is so much smaller than 78 is because a lot of those services were there to support the reckless microservice infrastructure. And so anything that was supporting the other reckless microservices, we could just throw away. And we only needed to migrate 43 of them. In the process of actually going through the migration, when you're about to migrate your service, you ask yourself, do I really need this service? Does it spark joy? And in some cases, we sort of merged 2 together, and we ended up at the end with only 31 services migrated to Docker. Everything else gone, which is pretty satisfying. Turns out if you have 100 microservices, maybe you only need 31 of them. So the original cost, so this is still only a small fraction of our overall AWS cost. The Windows hosts that were just running the services, so not all of the supporting infrastructure, just the host running the services, cost about $145,000 a year. In our estimates, we thought that if we moved it to Linux, that would firstly cut 45% off that cost. And we also thought, if we run them in Docker, we might be able to like bin pack them a bit better onto a smaller number of machines. So we thought we would get a certain saving from that as well. So this was the amount that we originally pitched in our project. We're like, this currently costs $145,000. We think we can get it down to $70,000 a year. When we finished the project, it was actually only $15,000 a year. Because we cut down a lot, like the sort of memory and CPU limits on those Docker containers, so we could pack as many in as we could. In the process, we found a memory leak issue that had previously been undiagnosed because the machines were so over-provisioned. And so once we removed the memory leak issue, we could pack them in a bit further. And this $15,000 is actually the shared ECS cluster with a number of other non-reckless services. So this is even an overestimate of how much it costs, which was fun. We also got rid of almost all of the infrastructure that was built to support reckless. So we got rid of the infrastructure hosts which was like another cost. It had build servers specifically for reckless services. It had the proxy system that hooked into the service discovery. We still use the console service discovery because we're using that for all of our Docker services. So that's part of the new world, not so much part of the old world now. And we were sort of configuring those hosts with Puppet. That's gone. We had package manager, deployment tools. All of that was gone. So that was another $25,000 of savings off our AWS bill, which was pretty fun. So, I'm actually probably going to wrap up a little bit too early. If you're getting support for a cleanup project, I would highly recommend asking for a really small amount of time first, and then using that time purely to validate your ideas and justify whether the project is worthwhile, right? If you can show that you've tested the idea and that the idea is going to provide the company with a lot of benefit, it's a lot easier to get your manager to agree to let you spend a lot of time on a project. You really need to demonstrate how this is going to benefit the business. Like, it's nice to live in a world where we could just write awesome software and not have to worry about whether it makes money or not, but in the real world, we generally have to make sure that there is some benefit, and it doesn't have to be a cost saving. If you can demonstrate that a series of production incidents could have been prevented, or a series of new features that would provide customer value would be much, much easier to develop. Often you find that there's like a cool feature that customers want that you don't actually work on because it would be inconceivably hard to do, because it would stretch some other piece of infrastructure to the limit. And so doing the cleanup work then kind of says, well, in the future, that will be much easier to do and we'll actually be able to provide customer value in the future. And one of the keys is be really, really realistic and very detailed in your time estimates. Most of the time when engineers underestimate how long it's going to take to do a project, it's because you haven't really thought through in enough detail how many different steps there are involved. And then individually saying, well, each one of these steps is probably going to take at least a day or two. And then once you add it up, you're like, oh, that's a surprisingly large number of days that will take this project. When I first, one of the two engineers that originally pitched this idea of like, hey, we could move it to .NET Core, I asked him like, oh, how long do you reckon it would take to migrate everything? And he said 2 weeks. And it did not take 2 weeks. So yeah. But overall, I have really enjoyed working with .NET Core. It seems to work really well in Linux. It seems to work really well in Docker. I would say the biggest problem that we hit was when we were diagnosing that memory leak. We had the problem that the tools that we would use to do a heap analysis and find out what was causing the memory leak only worked on Windows. The tooling was not there for doing a similar thing with .NET symbols and all of that kind of stuff in Linux. So some of the performance analysis tooling, there are things that you can use. CPU usage analysis is pretty there. Memory analysis, we ended up running the service in Windows again, just so we could do a heap analysis of it. So that would probably be the thing that's missing the most from .NET Core is that tooling around doing a like formal performance analysis. But overall, actually pretty good, like migrating stuff to .NET Core. You just have to be quite wary of, are you using parts of the .NET framework that are not supported? And are your dependencies up to date? Because if you keep your dependencies up to date, you'll have a much easier time with this. So that's the end of my talk. Are there any questions? Ooh, we have some. Cool. I think, I thought I had the memory leak graph, but maybe I don't. Okay.
So you've already pointed out that, I guess the main question I want to ask is, the fact you had dependency out of date, is this been able to push through your management and stuff, the need to actually keep things up to date? Because like Docker containers and such are fairly famous for having stuff out of date.
Right.
So is there a push now to make sure any code release and stuff runs on more recent libraries and stuff?
It has gotten better. So we did later on do another sort of 2-week Spike project to see, would it be possible to migrate the monolith over to .NET Core, which we found out that actually, no, we're not ready for that yet. That was also a successful Spike in that we found out the project was not actually a good idea right now. But one of the things that came out of that project was, wow, a lot of our dependencies are out of date. That is a large part of what's making this project difficult. We should update those dependencies anyway for a number of reasons. And so we started a bunch of projects to do like large updates of all of the dependencies in the monolith. So yes, it has changed a little bit. We're probably still letting our dependencies lag a little bit too much, but it is a lot easier to convince a manager, hey, we really need to update those dependencies because remember that time in the reckless migration project how like 90% of the work was updating dependencies, right? If we want to be able to do projects like that in the future, keeping everything up to date in smaller increments is a lot easier. So it has a little bit, yes and no, kind of changed the culture a little bit there. Yeah.
Thank you for the insights. It was interesting when you said you had to go back to the Windows to diagnose the memory leak. How easy is it for you now to basically parallel test? Do you parallel test on Linux and Windows, or do you just focus on the Docker-centric Linux deploys?
So when we run the tests on our build servers, we just wholesale, like we run tests on the Docker image, like in the same Docker image that it's going to be running. So when we sort of run the tests, it's usually in Docker. But our developers are all still working on Windows using Visual Studio, using Windows tools. And so when they're running the system locally, they are running it in Windows, generally, locally. So there is a risk there that as you're developing in Visual Studio, you might not notice that you're depending on a case-insensitive file system. So in that case, we are testing on Windows, but since we're running things in Linux in production, there is a bit of a disconnect there. We don't actually generally care that it works in Windows because we only run it in Linux in production. So this is probably not a good example of like, if you want to maintain something that is cross-platform, that's not something that I've done. That disconnect between Windows and Linux, I probably should have put this in the talk. There's a really cool tool in Visual Studio. So .NET developers tend to rely a lot on the debugger and stepping through things line by line, which is really great. Debugging tools are awesome. Visual Studio has support for running the debugger in Docker. So you set up your Visual Studio solution to have a Docker compose file and a Docker dependency, and it's just one click. It will start up the service in a Docker container that's very similar to the one that it will be running in production. And in Visual Studio, you are still stepping through the debugger as normal. And so if they need to debug something that's only going wrong in Linux, then you can do that in Visual Studio. You can do that running locally. The matching between prod and local is really nice when you're running things in a Docker image. We don't tend to use that very often because we haven't encountered many problems where it works on Windows and then doesn't work on Linux. We just haven't seen those issues very often. But if we do see them, and we did see them sort of once when we had those file name issues, then yes, it is quite nice to do local development in Linux on a Windows machine with Visual Studio, which is quite nice. It's just a lot slower. Like the debugger is noticeably laggy while it's debugging into a Docker container, which is why the developers don't do that all the time, but it's there if you need it. Yeah.
Just back on the out-of-date dependencies issue, have you found that the version pinning to older versions was there a conscious choice made to do that? Is it just a cultural thing, or is it a response to being burned too many times by a NuGet package that's supposedly compatible but isn't? Well, yep. And how do you find, has that changed at all between your previous architecture and your new one?
I find that hasn't really changed. Our Docker images are probably just as out of date as our dependencies were in the microservice world. It's kind of a problem that our developers hadn't really encountered until they moved to microservice land. Because when you're working in a big monolith, as soon as you need some new feature of a library, it forces you to upgrade that library everywhere. But if you're in microservices, you only need to upgrade that library in the one particular microservice that you're working in. And once you've launched a microservice to production and you're not actively developing it, you tend to forget that it's there. This is one of those hidden costs of microservices, is that it's a lot easier to ignore things that are slowly bit rotting and getting out of date. Because you're not deploying them very frequently and you're not having to deal with the code base very frequently. So yeah, no, we are in some areas getting better at keeping our dependencies up to date, as I mentioned, but generally, no, we're probably just as bad at keeping up dependencies. To scan through dependencies and sort of check for them. The security team is working on automatically scanning dependencies for known vulnerabilities. So are we depending on something that does have a security issue associated with it? But as far as I know, that isn't finished yet. So yes, yeah, I would love tips on like how to do a better job of keeping our dependencies up to date, because we have not solved that problem. Yeah.
Great result, by the way. Just wondering if you, because you are using AWS and EC2 instances, have you launched anything in using the serverless platform, Lambda, and is the migration from Windows to .NET Core, do you see that as a path forward for perhaps taking some of those microservices and moving them to serverless?
We have a number of cases where we have been starting to run stuff in Lambda. Yeah, if you think moving to Linux is cheap, moving to Lambda is even cheaper. Yeah, we haven't done that in terms of, we haven't looked at that in terms of migrating a lot of our sort of core serving over to Lambda. It's been individual cases where we're building a new thing and gone, oh, this thing would actually work really well as a Lambda, let's do that. Some of the Lambdas are .NET Core. We've definitely become a very polyglot kind of engineering team. So some things are in Java, some things are in Go, some things are in Python, and some things are in C#. And so it does make things a little bit inconsistent. We haven't solved that one yet. Yeah.
Did you find there was any training or upskilling required for any Windows-centric .NET devs when you moved to this new architecture?
There was absolutely a lot of learning required when we first started using Docker and running things in Docker on Windows. Sorry, on Linux. But by the time we started this migration project of the existing .NET Core stuff, most of the developers were very familiar with Docker, and so it was just taking your familiar C#.NET and merging it with your familiar Docker tooling and environment, and that was actually pretty straightforward because we made a conscious effort to use as much of the existing Docker tooling that we already had and keeping it consistent with the things that the developers were already familiar with. So yes, moving to Linux and moving to Docker and all of that stuff was a huge learning curve for our developers. But then adding C# and .NET to that mix was easy.
Last question.
Last question. We are a little over time. Yep.
Hello.
Hi.
So with Windows, .NET Framework's part of the OS, and you've sort of got that one copy running. And with now 31 Docker containers, you'll have like 31 different .NET runtimes running.
Yep.
How do you manage to pack it down to still, shave 90% off the EC2 bill and still have more .NETs running?
So how do you sort of pack it down and have like many .NETs running in separate Docker containers on these machines?
And still use less resources.
And still use less resources. So a big part of the problem was that they were massively over-provisioned before. When you're running multiple Windows services on the same hosts, there isn't a lot of isolation between them. If one of them uses all the memory, the other ones are going to suffer. And so they had tried to scale down those instances. Because of the memory leak, they weren't able to because it would start to break things. So I think there is an element of .NET Core running on Linux is just generally more efficient than .NET Framework. But mostly it was, they never needed those resources in the first place. And we just put them in smaller containers, smaller boxes, so that we could pack more of them in. So it probably is still quite over-provisioned, to be honest. But the cost is not worth us digging into it further. Yeah.
Thank you, Katie. Big round of applause.